The project description introduces a simple GitHub Actions workflow specifically designed for a continuous integration and continuous deployment (CI/CD) pipeline applicable to private GitHub repositories. The pipeline is tested on a Digital Ocean droplet, which is effectively a virtual private server (VPS). In the motivation section, the author outlines the limitations of existing workflows that only focus on running unit tests and deploying without managing dependency installation or process control. This new repository aims to address these gaps through a simple GitHub Actions workflow. The installation is very simple, as shown below. The GitHub Actions secrets subsection emphasizes the importance of securely setting the VPS IP address and the private key secret, linking to detailed instructions for doing so. In the VPS section, the focus is on the CI/CD pipeline, assuming that the VPS is pre-configured with essential software and user accounts. This enables a seamless deployment process without additional setup in the initial stages. The usage section is very simple, as shown below. The general subsection advises users to push changes to the main branch during the final deployment stages. It also suggests using the act command to test workflows locally without needing SSH, enhancing the development experience. The tweaks section recommends personalizing the simple CI/CD.yml workflow file according to individual needs, including options to change the default VPS user, omit token steps for public repositories, and use cron jobs instead of PM2 for process management. The Technologies Used section lists various technologies pertinent to the project, including GitHub Actions, Ubuntu for the Linux environment, Digital Ocean as the VPS provider, and several coding languages and tools such as Node.js, TypeScript, PM2, Act, and Vitest. This section outlines several design considerations. In the Goals subsection, the key objectives for the CI/CD pipeline are stated, including the need for an automated workflow triggered by repository pushes and ensuring that previous application versions can be retained for easy rollback. The Questions subsection explores several queries faced during the workflow's development. It discusses the choice between using only bash commands for simplicity or splitting tasks into scripts. It emphasizes having a clean error handling approach through script exit conditions within the workflow. In the Docker subsections, the author contemplates the necessity of Docker, concluding that the current VPS environment is sufficient for CI/CD tasks without additional Docker layers for complexity. The Code Structure section outlines the project structure, indicating that the workflow is defined within a YAML file named simple-cd.yml, located in the .github/workflows directory. The Workflow Variables subsection lists various environment variables crucial for the CI/CD operations. It includes keys like user, VPS IP, and app name, which help manage the application's configuration dynamically throughout the workflow. This section outlines crucial workflow steps involved in the process, including actions to check out code from the repository, configure SSH for secure access, and transfer necessary credentials to the VPS. The workflow continues by detailing commands to securely transfer the GitHub token to the VPS for operational use in later steps while maintaining security by deleting it afterward. Further actions include cloning the repository onto the VPS and installing necessary dependencies using the npm package manager to prepare for running application tests and builds. The steps clarify how to stop the application using PM2 if it is currently running. This step includes checking the process list for the application's name and executing the stop command if found. This portion of the workflow moves the existing working folder to an old version and sets up the new clone as the working directory, ensuring a seamless update process. It finishes with steps to restart the application using PM2, checking whether to start a new instance or restart an existing one based on the current process status. The demo section showcases successful outcomes of the workflow run, illustrating its effectiveness with images hinting at clear success markers through operational deployment. The second image in the demo section reveals additional workflow details, emphasizing the last execution steps to further confirm the successful run. Points of interest highlight various insights about the workflow, such as their usage of the ACT tool for local testing, the method for uniquely identifying repository versions on the VPS, and the perspective on using the github.run number for maintaining consistency with each workflow run. Future work provides a roadmap for expanding the workflow capabilities, including making it more generic, experimenting with real-world applications like Next.js, and improving security practices regarding the GitHub token handling. The References section curates a list of useful links to videos that elaborate on GitHub Actions, their efficient local testing, and deploying workflows for private repositories, all resources for further learning.